Hey guys, we are back with our third video. We're going to do example number 8 from our lesson. And now we're getting into some fun examples because now we're going to start looking at problems that have too many variables for the number of rates that are in the problem. So when we read this paper cup problem, we're talking about a rate of water dropping, and we're talking about a rate of volume, centimeters cubed per minute. So we're only talking about two rates: change in volume with change in time, and the height, change in height with change in time. But yet our formula has three variables. And again, we're putting time in here because it's minutes. So dv dt, dr dt, dh dt, too many rates. So we have to figure out, like we did back in our problems at the start of this unit, how do we reduce the number of variables in our problem? And inside this cone, we're getting information. And we want to talk about how radius and height relate to each other. So that's why we're not talking 8, we're talking 4 for the radius. So we're going to relate radius and height and get the radius out of the problem, because we don't want radius as a rate, we want height as a rate and volume as a rate. So our objective, before we even start the problem, is to figure out how to simplify our function. A little bit of similar triangle idea. Radius to height is always going to be 4 to 12. It doesn't matter where you are. If you're halfway down, it's 2 to 6. If you are near the bottom, the radius is 1 and it's 1 to 3. And that's the simplified version that we have here. Radius to height is always a ratio of 1 to 3. So a little bit of early math, a little cross multiplying. We know that the radius is always 1/3 the height. Look at your formula. 1/3 pi r squared h. Put the 1/3 h right in for r. So it's 1/3 h squared. So now we're going to do a bit of math, and we're going to simplify. 1/3 h squared is 1/9 h squared. Going a little bit more math yet. H squared times h cubed, 1/3 times 1/9 is 1/27. So we are finally at the first step that we have to have before we solve the problem. Our number of variables equals our number of rates. We have volume and we have height. So that's step 1. Step 2 now is, again, before you try and deal with solving the problem, you got to put the rates into the problem. And we said we want to talk about volume changing in terms of minutes. So it's got to be dv dt. And again here, 1/27 pi, those are just numbers. H cubed, derivative of h cubed is 3h squared. H's and t's don't match, so that's why it's dh dt. And then clean up your fractions. 3/27 is 1/9. So we finally got the variables to match. We got the rates in. Change in volume is 1/9 pi h squared dh dt. So now we want to solve for the moment in time. Again, look at the problem and understand that we're talking about it when the water is 3 centimeters deep. Man, we're being nice again. We haven't had to do any work yet to figure out h. There's going to be questions at some point in time. We're going to have to figure out your own h. So we needed the h. We were given h. We need dv dt. We are given dv dt. The volume's coming out at -2 centimeters cubed per milliliter. Put everything in. Multiply, a little bit of fraction skills. 3 squared is 9. 9 divided by 9 just kind of goes away. A little more cross multiplying. And how is the height changing as the time is passing? Simplify. I think we said in our problem, nearest hundredth. So the water is dropping. It's negative at 0.63 centimeters per minute. Okay. So that was a little better problem because we had to do some preliminary math to reduce the number of variables in the problem, and then we had to put the rates in again.